This recording is with regards to Unit 4 on the binomial distribution. And we are familiar with this notation. A random variable x approximates a binomial distribution B with a sample size n and probability of success p. So the probability of x equal a certain value is equal to n combination r, p raised to the r, 1 minus p raised to the n minus r. The population mean is, or the expected value is calculated by the product of n and p, and the variance is equal to np times 1 minus p. And as we know, the standard deviation is the square root of the variance. So this example 4.2 is saying that, is asking, well, this is outlining that the probability of a student passing an exam is 45%. So the probability of succeeding is p equal 0.45. And 20 students take the exam, so n is equal to 20. So that's a classic case of binomial distribution, whereby the random variable could be, yes, it says, well, part A says to state and describe the random variable, find the probability that out of the 20 students, exactly 15 pass and at least 2 students pass. But off the bat, you can see where the random variable would be the number of students that pass, okay? And that could be denoted by x, and the probability of a student passing is 0.45 out of the 20, n is equal to p. So let's look at the solution. So the question is state and describe the random variable. Okay, so the random variable there would be the number of students who pass out of the 20 students. And to describe now that random variable, we can denote it by the letter x. So anytime you see x in this question, you have to see the number of students who pass out of the 20 students. So the number of students who pass out of the 20 students approximates a binomial distribution. So B, capital B is missing there. Okay, so please take note of that. And the sample size is 20 and the probability of success is 0.45. Okay, the probability of obtaining a student who passed if each independent trial is 0.45. So this has a little error missing the capital B for binomial distribution. So here it has been inserted, B for binomial distribution. At B now is asking, what is the probability that out of the 20, exactly 15 students pass? So R now would be 15 and N keep on being 20. So using the formula n combination r, p raised to the r, 1 minus p raised to the n minus r, 1 minus p would be 1 minus 0.45, that would be 0.55. So that would be 20 combination 15, okay? The probability that the number of students that pass is equal to 15 out of the 20 is 20 combination 15, 0.45 raised to the 15, because r is 15, and 0.55 raised to the 5, because 20 minus 15 is 5. And that will be 0.0049. So that's just a clear, simple substitution into the formula. Now, Patsy is asking, out of the 20, find the probability that at least 2 students pass. At least 2. At least 2 means 2 or 3 or 4 or 5. Bear in mind, or in probability analysis, you have to add. Once you mention the word or, you've got to add. So at least 2 means from 2 right up to 20. So that's 2 or 3 or 4 or 5. So you got to find, if you have to do it this way, if you have to take this approach, you'll have to find, you will have to use this formula with 2 right up to 20. Okay? So that's a lot of work. Okay? But we know that the sum of all the probabilities in an experiment is equal to 1. So why not find the probability of 0 and 1 and subtract it from 1, then you'll get from 2 to 20. Okay? So that's what is being done here. So here it is, denoted probability that the number of students who pass is at least 2. At least 2, the symbol, the notation for at least is more than or equal to. Okay. The least amount, 2 or more. So more than or equal to 2 is equal to 1 minus less than 2. Okay. Take note that the probability of x less than 2 is the same as the probability of x less than or equal to 1, because we're talking about a discrete random variable. So less than 2 means 1, because less than 2 doesn't include 2. Less than 2 starting from 1, 1 to 0. Okay, so please take note of this very important notation, observation, that less than 2 is the same as less than or equal to 1. So the whole point is that we have to do from 1 and 0, apply this formula for 1 and 0, 0, 20 combination 0, 0 0.45 raised to the 0, 0 0.55 raised to the 20, okay, and 20 combination 1, 0 0.45 raised to the 1, 0 0.55 raised to the 19, add them together and subtract from 1, that will give us 0 0.9999. So there is almost a 1% chance that at least 2 students will pass the test. Okay. So take note of this approach instead of calculating from 2, 3, 4, 5, 6, right up to 20. You can just do from 0 to 1 and subtract it from 1, because the total probability in any experiment is 1, and then you get your answer, which is 0 0.9999. So here's the question in its entirety and the solution.